We are Group 7. Our project is about advanced materials for clothing. So, as we know, recently there was a serious mystery in Kowloon Bay. As many of you know, two firefighters were killed by the fire in the mini storage. It was thought that the current firefighters suits are not air fluent, which make the firefighters very hot and tired when wearing them, especially in summer. There were many discussions and voices from the society that the golden suit is not that safe. Therefore, we want to find out the problems in the firefighter suit. We think the imperative thing is to change the materials or the composition of the shoes so that the temperature inside the shoes can be lower and increase the mobility of the firefighters when entering a fire scene. Firefighters put their life at risk in each operation. They need to do a bunch of things inside that dangerous condition to rescue people. So we choose this topic and want to improve the current suit of firefighters that can protect their lives.
Let me tell you the most common models of firefighter suits nowadays, which is European style firefighter suits, which is called PBI matrix. Most of the countries around the globe are using this suit. It mainly consists of 3 layers. The outer shell is made up of PBI cover, delta T, and kernel. The outer layer is used to protect the wearer from flame injuries. The second layer is moisture barriers, which consists Gore-Tex, fire blocker, and Proline. Moisture barrier is used to give protection from external water penetration and allows internal moisture vapor to escape. This reduces heat stress the firefighters suffer. The third layer is thermal barriers, which involves normal viscose, normal delta C, and FR cotton. This layer provides heat protection from proximity to flame. This suit weighs around 4 kg. There are mainly 3 problems of the current suit. The first one is low ventilation rate. PBI matrix used nowadays can completely protect firefighters from the effects of most of the possible fire conditions. However, the PBI matrix in the outer shell becomes bad ventilated when it is wet. This reveals that since PBI matrix is a good heat-retarding material, it can withstand high temperature and is a good insulator of heat. However, when the firefighters are feeling hot, the temperature inside the suits are already very high that the firefighters are too late to leave. The fire has already caused damage to them. This will probably lead to heat exhaustion and even heat stroke. Therefore, some firefighters describe the European firefighter suit as a thick down jacket. The second problem is that PBI has relatively low tensile strength, especially in Hong Kong, which is a humid city. PBI fiber degrades in most environments, and thus the fiber used in firefighters' clothing loses its mechanical properties in fire. It was reported that PBI fiber loses 30% of its tensile strength after the exposure to the environment and at 50 degrees Celsius and humidity 60%. The last problem is that prolonged sunlight and UV exposure can be damaging to PBI matrix. This will lower the tensile strength of the suit. Therefore, the deterioration rate of PBI matrix will be higher than other material. Also, it is less durable.
Due to those drawbacks, a few incidents have happened. For example, in May 2008, some firemen who were wearing European firefighter suits joined a fire drill in Taipei. However, one of them discovered that there were huge damages on his clothes after he went to the scene of fire for merely 10 seconds. Worse still, he finds that he's getting hotter. Even his skins were burnt due to the fact that the fire-retardant clothing has deteriorated, so it could not withstand high temperature to protect him from danger. Besides, a deadly auto-gun blaze happened in June 2016. The fire started in the morning and quickly escalated to level 4, which is nearly the highest level in Hong Kong that evening. It was extinguished after burning for more than 108 hours, which killed 2 firefighters. Some professionals doubt that the tragedy is probably because of the poor dissipation of European-style firefighter suits that caused heat stroke of the firefighters while battling in the infrared.
And the characteristic of firefighting garments are not only flame resistant, but also resistant to some other environmental hazards, like chemical substance, extremely hot moisture, a vapor, or some erosive objects that may hurt the firefighter. Since nowadays, fire protective cloth PBI matrix was designed by American company. It is not exactly suitable for the condition in every country, especially in Hong Kong and Taiwan. Both of them are in subtropical region and the relative humidity and temperature is higher than that in US and Europe. So that we want for the cloth, what we want for the cloth is not completely the same. And therefore we try to make the cloth more breathable and resist to UV. The resistance to heat may be a little bit lower, but it can still withstand high temperature. Our new design of firefighter protective clothing focus on the ventilation and the UV resistance problems. For the outer shell, Canos is used as the building fiber instead of PBI. Canos is more resistant to UV when compared with PBI. And you can see from the table the deterioration rate of PBI is twice that of Canos when exposed under UV. So after a period of time, the strength of the PBI fiber may become weaker and weaker, and it may easily melt at high temperature and hurt the firefighter, just like the news in Taiwan. Also, Canos has a higher limited oxygen index than that of PBI. That means Canos need more amounts of oxygen to support combustion, so the degradation temperature is also higher. So the chance of the cloth being burnt is lower and it is more safety. And besides, we try to use climate cool technologies inside the thermal barrier. Our company Adidas has used this technology for making waist shoes and the material used is called Lomas, which is a fire retarding material. Cool Lomas pull the sweat away from the body and increase micro ventilation through mesh panels, so the clothes become more breathable.
When it comes to the difficulties of making a new firefighter suit design, the optimum percentage of different materials is essential. Since different materials have different functions, we need to adjust the ratio of different materials so that they can work best in the fire to protect firefighters. Whereas plenty of resources are required while doing experiments to investigate the optimum ratio of different materials. Therefore, we may find it difficult to find sponsors to support us doing experiments, which is quite costly. In addition, we involved Cool technology as our design, which is owned by other companies. They may not be willing to share the patent with us for making new firefighter suits. These could also be the difficulties. We also find it's hard to make and handle the materials required. For instance, the filament of copper is produced by spinneret. Besides, specially made scissors are usually required to cut the dry fiber and laminate. When handling the firefighter clothing, make sure that we don't stretch or compress them, and prevent any stain on them, as this will lower their fire retardant efficiency.
So we are going to introduce you future development of the suit of the firefighters. So in no way dare we deny that the suit of the firefighters needs to repress the heat in fire. In the future, we suggest we can put some phase change material PCM, which is achieved through the solid to gas or liquid to gas form between the cloth layer, like the principle of the liquid warmer. PCM can avoid the body of firefighters absorb less heat. The heat can store as latent heat in the PCM. So why would we have this idea? Because we can see there are many advantages inside PCM. So PCM, like they had a high energy storage density, able to melt concurrently, and chemically stable. So we believe that the future should have also have some pipes to let the gas that had experienced phase change out. This way can reduce the weight of the suit of the firefighters. But basically, this is just the initial idea, which is not proved yet. So maybe we make a conclusion. After doing this project, we find that the current firefighter suit has a few loopholes that will cause serious effect on firefighters. Therefore, we redesigned the firefighter suit that can prevent the irresistible rise in temperature in the firefighter suit, have higher tensile strength, and are more resistant to UV light. So we believe that our design will reduce the catastrophes of firefighters. We hope that it will be adopted one day. Thank you.